What is going on, guys? My name is Hussein, and in this video I want to build with you guys a URL shortener. So we're gonna go through a system design interview questions, or this is one of the most interesting ones, right? It's very common and it's really easy to build. But before we jump into the video, guys, I want you to always, for any of these exercises, design, system design, you are the system designer. And I want you to treat whatever this is the blank canvas that you put your own unique design in. Okay? And be proud of whatever you put in there because it is an art, right? I consider system design as an art. Some people might not agree, but there are literally thousands and thousands and thousands of ways to solve any given problem. And today's problem is URL shortener. So whatever I'm gonna come up with is not gonna be perfect. Whenever a 30-year experience professional either is not perfect because there's always pros and cons for every system design. And whatever you come up with, own it. Enjoy the process because it's gonna be your baby and it feels damn good if you designed something of your own without actually looking through the best practices, right? Before you jump into best practices, just do something. Do a bad design and start to improve it. Keep in mind that everything can be improved. With that said, how about we jump into the video and start building our all URL shortener. So what is a URL shortener? It's a system that you give me a whole large URL and I'm making it into a tiny URL. And if you give me that tiny URL, I'm gonna give you or redirect back to the original long URL. Very useful for social media because I don't, or very useful for, hey, take this URL. It's easy to remember than like a URL this big, right? All right, that being said, the first design that comes to my mind, and it's no longer, it's not perfect by any means, but the first design is, I'm gonna have a database here, okay, and excuse me guys as I navigate this thing, because this is the first time I do this, but yeah, there's a database. I actually like the other database, so let's put that there. I bought for you guys a special thing here. All right, so we have a database, guys. All right, this is a beautiful database. And all right, we have a database. How about we add a computer, guys? Right? Let's add another computer as the client, right? I don't know. Let's do this. Sounds good. Looks good. So we have a database. We have a client, but since this is kind of a web application, we kind of need also a web server, correct? So how about we add a web server here? A web server. Let's add a web server. There you go. That looks like a web server, right? So that's where our application logic will lie. This is my database. And this was the client that requests a URL to be shortened. And the same logic that revert a short URL back to a long one will live into the same code base, right? I think so, unless you guys disagree. All right, so this is a database, and here's the first design that comes to my mind. I am going to use a table like this in the database, right? And it's gonna be like an ID, and there will be another field called URL, and pretty much that's it. That's it. The long URL will come here, right? That's the long URL, right? The long URL. Excuse my handwriting here, guys, but I'm still working on this sketching pad thing. And this guy is gonna be a serial field. And in Postgres, there's a serial field, and essentially a serial field, like every time you add a row, a new row here, this will be auto-generated for you. So it's gonna be 1, right? Or 2 and 3 and so on. And then it's gonna be a 64-bit, so the maximum number we're gonna get is 64 minus 1, which is a huge number. How about we actually check how big is this number? That's the biggest 64-bit integer. Look at this. It's really, really huge, right? It's around 20 digits. right? 20 characters, if you will. So obviously it's a huge number, right? So this is how many rows I can have in my table, right? But it is big. You can store this much URLs, right? So what will happen here is if you made a request, right, you will just specify the URL. And I think that's enough. We're gonna walk through that, right? So let's say I'm gonna shorten a big URL and you're gonna start writing this here and you're gonna get a number, right? So let's walk through an example. How about that, right? I'm gonna make a post request here, right? Post request slash, and you're gonna give a URL, right? Okay, that the post request will be received by the server, and the server will establish a TCP connection to the database, right? I'm assuming I'm gonna use MySQL or the Postgres. I'm going with relational for consistency reasons here. So now I'm gonna establish a connection here, and I'm gonna write, right? So this is an insert statement. Immediately I'm gonna do an insert, SQL's insert, and I'm gonna specify the URL. And what the database will give me back is a number, either 1, 2, give me which sequence ID. And that, I'll take that sequence ID and I'll return it back to the client. So the URL will be /1, /2, /17, and so on, right? So that's the original design, right? Let's go through that, and we're gonna talk about the pros and cons of this design, obviously, guys. But that's one design, right? If you don't really care about having custom URLs that work, right? But let's break down the database design a little bit here. Since this is a database, a relational database, I want this to have an index. Can I change this color? Yeah, I can change this color. How about that? I'm gonna have this as an index. I need an index on this, right? Probably a primary key. That's gonna be my primary key, right? And it's gonna, by default, it's got primary key, it's gonna have an index. So look up on this guy is gonna be extremely fast because it's an integer. It's only 64-bit, so the index size is so tiny, right? Plus, we don't really make a GET request example. I'm showing you a GET request. So let's walk through a GET request example. So the client will make a request, says, hey, get /7, right? I want the URL /7. It's going to be the domain /7, right? And that server will receive that. It's going to make a query, and this time it's going to be select, right, to the database. And the database will select where ID is equal 7. My God, how fast is this? Because this is an indexed column and it's an integer, so the index is so tiny, right? So the query will be extremely fast. And we're gonna get back the results. So okay, this is the URL, and the server will return that and will return the URL to the user. Sweet. So that seems okay. That seems okay, right? So the only index technically that we need is just this. We don't need another index, and so extremely fast. So let's start to scale this up a little bit. I'm posting a lot of URLs, right? And I'm getting this incremental IDs, right? So I'm gonna get up to like 1 million or 2 million, 3 million, right? Does this database can handle? Definitely can handle. Databases can handle 3-4 billion records easily. And writing, will writing become slower if I have like 1 billion rows here? Absolutely not. Well, we're going to talk about that, because writing here, I'm not querying to write, and I am guaranteed that this ID is always going to be unique, right? I'm not querying the database to check if it exists or not. The database, I'm only writing. So writing is absolutely fast. And every time I write something, I'm going to always get a new ID, right? So I don't really need to query. How awesome is this, right? Immediately get an ID. Every time, whether it's 1 billion row, whether it's 3 billion or 1 trillion, writes is gonna be fast because writes at the end. Now, if you want to get a little bit technical here, this database, if it's a B tree, right, based database, like the storage engine is a B tree, then writes are gonna get slower and slower the larger you get, because This index is a B tree index, and as you guys know, with B trees, we try to balance those trees, right? And I'm gonna make a video about B trees maybe. And as I start writing, those B trees was gonna be get slower to rebalance because we need to reshuffle the trees and move the data structures around. So writing is gonna be slower the more data you have. But if you're using an LSM tree, right, like Cassandra, well, Cassandra is not a NoSQL. Let's take NoSQL out of the equation. Let's say you're using RocksDB, right? MySQL Persona, for example, RocksDB, or MyRocks, right? So MySQL can be configured with an LSM engine, and LSM engine is, in this case, is going to be the best because writing is going to be so fast. Now, let's jump into, I think that we talked about the URL, we talked about the table design, we talked about the querying here, and looks good. This isn't, I'm not introducing any caching or anything, guys, right? You can introduce caching, but let's just make it simple. This code is gonna be so short, right? The code to generate this, and I'm gonna show you the code as well, hopefully. I don't know if I'm gonna go through the code, but the code is really easy to write here, right? So that's the first design. Is this perfect? Absolutely not, because Hussein, I don't like this /7/a/10/that because it's very predictable, right? That predictable design is gonna, you can predict the next URL very simply, and that's not a good idea for hackers. Like if you give, don't ever give the attacker the clue of this incremental predictable IDs, because they can do bad things with this, right? But if you don't really care, right, and they use this like these URLs are public anyway, right? That's okay. But what they can do is essentially they can scan your database, right? Because they can just write a code to loop through all the IDs from 1 to 1 billion, and they can retrieve all your URLs. I don't know why they're gonna do that, but they can, right? So the predictability is essentially for attackers is bad. So some people don't like this. I am absolutely fine with it sometimes, especially with the benefits that gives us. Like this gives us extreme good reads and extreme good writes as well, right? Reads are good and writes are good as well. Isn't that fantastic, right? Let's change the color back to white. All right, so that's what we want to do. Isn't that awesome, guys? So that's the first design, the numbers design. Okay, the pros, we talked about pros, very fast write and read, but the cons is the predictability, right? And also the no custom URL. There's no custom URL on this stuff. Yeah, there's no ideas like, oh, give me, I want the URL to say, oh, this is a Kindle, Amazon, whatever, right? This is as Amazon is an Amazon one, right? Or this is my presentation for the executives. You cannot do custom URLs. If you don't want to do that, if you want to support custom URLs, this design is useless, right? So how about we jump into another design? Let's clear out this mess, guys. Ugh. Yuck. How about that? We're clean, guys. We're clean. We're back. All right, so design number 2, which is what? What are we designing, guys, here? We are designing a system to support custom URLs in this case, right? And also we don't like these URLs that start with numbers, because I don't want to give the attackers ideas of that's predictability, right? But the original design was good for like automated Twitter URLs that the only system will auto-generate these URLs and store them in that way, and the user will never actually see them short. They always gonna see them long, right? So you can use that original design if the user is not gonna see those, right? But it's absolutely beneficial, right? System number 2 is I want to support custom URL. So that means if I want to post, right? If I want to post here, right, make a post request and then slash this URL, and then I want to also specify the custom URL. So yeah, I want to specify the custom URL and yeah, custom equal whatever. ABC, right? So I want to specify how the URL will be stored in short form, right? So this is a post request. Well, how are we gonna do this, right? Let's think of the table design. How are we gonna store this thing? Well, in this case, I still need the URL, the actual long URL, and there's no escape. We need the short URL, SURL, right? That's how it's gonna look like, okay? And I'm not sure we're gonna need a primary key. We'll come to that, but these are the two columns in this case, right? So now, if I come in with a URL and I want to post, that means I want to write. I want to take that URL, long URL, and make it into a short URL. So what are you gonna do? So many ideas. The first that comes to mind is to to hash it, right? And generate, I don't know, 256 byte, or which is like equal to 32 byte, right? Which is a huge character, right? And then take, for example, the first 8 characters, if you want just an fixed 8 byte characters, right? And you can do a base 64, right? So they look like these YouTube URLs, right? Which is like, let me show you. So this is how base 64 URLs look like, guys, right? It's a characters from A lowercase to Z lowercase, from A capital to Z capital, and then all the numbers and plus signs and all the garbage, right? So that's how a base 64, right? And YouTube only use this much, but it can serve them forever, really. It can give them a lot of characters, right? So yeah, let's just enjoy and have fun, guys, doing this stuff, right? So we're gonna start what? 8 characters, right? So 8 bytes. Take the first 8 bytes and make them into base 64. So that's the character. So we're storing technically 8 bytes here, right? And it's like A, B, C, whatever. And this is the long URL, okay? And technically, what I want to do here is I'm gonna make this into, let's use another color. I'm gonna make this into a primary key, right? So I want to prevent multiple same URLs from getting collide, because now in the previous design, you don't have collision. You will never have collision. The problem of collision doesn't exist, guys, right? But here, now you have a problem of collision, because now you're showing hashing and you're taking a huge string and making it a smaller string, which is the idea of collision always exists. So 2 ways of solving this problem, okay? Take that post request, do this operation, get that 8 characters, and attempt to immediately insert in the database. Just insert, okay? Don't query, because querying is expensive. You insert, and the database will take care of this. If the insert was successful, you're gonna get a nice short URL, right? We're gonna get obviously you know the short URL in this case, unlike the first design where you only go the number, right? And then you're gonna return back the URL for you. If that failed, right, because it can fail, right? The insert can fail because of the duplicate primary key, then the web server here is responsible of regenerating a brand new one. And how do you know that, guys? Right? How do you generate a new one? I just use the URL and show it and took the base 64, and I'm going with, if I regenerate it, I'm gonna get the same one. So you need the idea of salting here, right? So that's one way of solving it. So you generate a random salt and insert it with the SHA, and then generate a brand new base 64, take the first 8 characters and then write it down. But the moment you do that, do you really need to store the salt? I'm not sure. We'll think about it. So guys, I didn't really think all of this through and prepare the best design for you. I'm just walking through your shoes and doing it as if this is the first time. And I want you to just explore everything. That's the fun of this. URL shortener is, or any system design is a fun activity. I want you to have fun, right? So let's say I'm not gonna store the salt, because do we really need to? I'm not sure, right? So I'm gonna store it, and then yeah, we now have a brand new URL, right? Short URL, and then I'm now returning that short URL to the user, right? So there are there could be, let's change the color a little bit here and to green, and there could be some sort of a feedback loop here, right? Going back and forth, back and forth, back and forth, because hey, I try, got a collision, because it failed, I'm gonna try again. Failed, I'm gonna try again. Failed, I'm gonna try again. Failed, okay, you got the idea. So there could be a failure here, but you're relying on the database to give you the failure, and it's very fast because this is a primary key and it's obviously indexed, right? So you can have this loop of failure, and this could take a long time to resolve if you have a bad salt algorithm, essentially, right? But that's another idea. And now you can just you can also take that URL, right? So that's the idea of in case of I do not want, I want a random short URL. But if you want to take the user's input URL and hey, use this as a URL, that's easy, right? You just inserted it. You try to attempt to insert it. If it exists, you're going to get an error. And you, in that particular case, you need to return the error to the user, right? Because, hey, you supplied a custom URL and that is already exists. But in case if the user did not specify that, you don't want an error, right? So your code just became more complicated just because you want to support this custom URL thingy. Is it worth it? Maybe yes. Hussein, I'm sorry, but I need to do this. I need to support custom URLs. So you have to pay the price of this loop. You have to pay the price of this branching of the code. Oh, if the custom URL return an error, else do this, right? So there's like a lot of stuff happening here. Okay. Plus, your primary key index is now bigger, guys, right? I mean, nobody cares about storage these days, but how big it is. But now it's 8 byte. You can do the math, but your index is larger now. Your write is going to be slower because it's a string versus it's 8 byte for God's sake versus 64 bit. Well, 64-bit is 8 bytes. It's the same thing. But integers versus strings, yeah. And this is the same index size, so I apologize for that. But yeah, it's a character versus string versus just numbers, right? But now it's a better design, isn't it, right? I have characters, I have just random strings, instead of just predictable numbers that users can scan my database. I don't want them to scan my database to get all the URLs, right? So this is also obviously better. What do you guys think? Let me know in the comment section. You might say, hey, the first design is good, and the second design is, yeah, not worth it. We're going to say, no, this first design definitely does not working. The second design is better. You might say, Hussein, both designs suck. Here's a better way of doing it. And I would love to hear those. That's why we are here. This is a canvas of artists. You is English. You are an artist. Paint, guys. Just paint. Enjoy this process. Don't take things seriously. We're all gonna die eventually. So, okay, this is gonna get dark. Okay, so enjoy this process. All right, definitely faster. It's a good process, guide. So that's these two designs, and now I'm supporting custom URLs with this. Right? And I only needed 2 fields. Do you need another fields? Nah. All right, guys, how about we go through a read operation, right? Since we went a write, let's do a read. This thing is painful, guys, by the way, just deleting, clearing things. If you have a better way of doing sketching online, let me know in the comment section, right? I'm struggling around down here. So let's write our table again. We have the URL, right? We have the short URL, which is this 8 byte thingy, right? And that's our table. I think that's the only thing we need to store. And let's walk through this. I want to make a GET request here. And this is my short URL. I'm reading those URLs. Now, this my short URL says Amazon, right? And then we take that character, we take this string, and we query the database, right? Less bliss. Obviously, guys, we need to do as much sanitation as possible to not like, because someone was like, hey, Amazon SQL injection, semicolon, drop, table, URLs. They can do that and screw a whole our database. So sanitize your input, and this is easier than ever. Check out my videos on SQL injections and sanitation and all that jazz. So yeah, we're gonna do a select statement here, guys, where the blah 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 equal Amazon, and then we're gonna immediately query that, right? And that's fast because there is an index here, right? We built an index. So now this huge 1 billion rows is now smaller, but still good. I mean, people can do sharding and all that stuff, but I really recommend you not to unless your system is big enough to really need sharding. And I talked about when to shard and when not to shard. Check out the videos there. But yeah, I'm gonna query that. If I find it, I'm gonna return the actual URL, which is this guy, right? And then I'm gonna return it to the user. And by return, I mean literally just do a 301. Was it redirect 301 or 302? And do location equal this. So in order to immediately redirect that stuff, right? So maybe in another video, I'm gonna actually sit down and actually do the code for you. I just wanna make the video a little bit short. I don't wanna make the video long. URL shortened design. We gave 2 designs, and now I want you to just, while walking through the scenarios, what else can we do? Can we use NoSQL databases? Definitely. Can you use caching? Can you use Redis? Definitely. You can do a lot of stuff to optimize this. So what's the pros of this design? The pros, well, I have my beautiful custom URLs, and I no longer have this scanning problem. The cons, it's 100% slower than the first design, right? At least in the writing process. And you might say, I don't care, Hussein. I don't care about the writing process. And you're absolutely right, because writing, how often writing happens compared to reads? Reads is gonna be always more than writes, right? So always think about that. How many people click on short URLs versus how many people generate short URLs, right? Well, unless you're Twitter, if you care about reads, writes, right? Like for Twitter, right? Every time you go to a tweet and put a long URL, Twitter automatically shortens it. So, and Twitter have a lot of writes, right? So now, in this case, you might prefer the first design because you're gonna store that in a short manner and you're gonna retrieve it also in a short manner, but you're gonna show the user always the long URL so that they don't even know the short URL actually exists, right? So your first design might work. But if you're building an actual tiny URL custom for the user or bit.ly, this design absolutely works, right? And I didn't talk about scaling per se across the whole world for this, right? So let's talk about that a little bit before we end the video. So if I want to scale this design, right? Let's talk about this a little bit. Scaling. All right, scaling. Let's talk about scaling for both design 1 and 2. It's the same, I think it's the same problem, right? So let's talk about the scaling, right? Because that's what the NoSQL people have against the relational databases, that they don't scale. So scaling in this case, what we're gonna do, guys, and we can clear all that garbage, we don't really need it. But here's the thing, we will make one master database and multiple backup databases, right? And let's change that. Can I change the color on the stuff? I don't think I can, huh? Never mind. All right, I can't change the color. But here's the thing, guys. So this thing is gonna be the backup, and this guy is also gonna be a backup. What does that mean? A backup means it's designed just for reads, right? Because that's what you want to scale. You want to scale reads, right? And the writes always goes to one single database. So there's one single database in Central America, I don't know, North Virginia, right? And there is a process that pushes the writes to these read replicas. Okay, and this is called replication, the idea of replication, right? And this is like any relational database supports this by default, right? So now you can scale those guys, right? The web servers definitely can be scaled, right? You can put a web server here, you can put another web server right here, and you can point read. So you can absolutely point reads. When I say reads, I mean GET requests, right? Hey, give me this URL. Reads to this, point reads to this, right? And point post request to this server, right? This is the master or whatever, right? And this is the post request. And post request, I mean what? I mean actual writes of short URLs, right? So you always configure your system to have this, right? Reads, and you configure it to have writes right here, okay? So this can scale very easily, right? Because you remove the reads and now you associated this only with the writes, correct? So now this guy, all the reads can go to this server, and all the reads can go to this server, and you can do this all day, right? You can do this like if you're in the US, you can do this for the West, and this guy is the East, right? And reading is gonna be fine, right? There will be some sort of an eventual consistency, yes, guys, eventual consistency can happen in relational databases, right? Not only NoSQL, okay? But I am guaranteed that my writes are always consistent here. But there will be a lag where if I write something, right, and at the same time I try to read it, it's gonna be a lag, right? So sometimes you want this guy to always accept reads as well, if they're coming from the same IP address. But that's a detail that you can finesse, guys, right? So that's the replication idea. You might say, Hussein, that's impossible. One database cannot handle all of this stuff. Well, that's absolutely fine as well. You can now, if your writes can no longer scale, then you can go play with the idea of sharding, right? Which we discussed right here. Go check the video out. So you can shard this database only if you absolutely cannot handle the writes, guys. Again, you gotta really be careful. When do you want to shard? Because it's a very complex operation. And you can use MySQL, you can use Oracle. Oracle's so expensive. You can use MySQL, Postgres, all those relational beautiful databases. You can also use NoSQL databases, but I do not like the eventual consistency in on NoSQL databases, especially with writes. As that's just personal opinion, because I prefer to have consistent writes even in a single instance, right? But that databases don't even give you that. NoSQL database doesn't give you that, unfortunately. No, I'll take that back. So yeah, you can replicate this with a MongoDB, right? With writes. Your writes are going to be fast, but it really depends on how you're storing this information, the indexing on NoSQL databases. I don't know anything about NoSQL. I know very little, so I cannot possibly tell you to use NoSQL database like Mongo if I don't actually understand the underlying functionality, right? I know that not all NoSQL support indexes, which is something I just don't like, right? If you don't support indexing, that's just a big no for me, right? I need an index so I can quickly query my stuff, right? I need things that are predictable, right? That's just me, guys. Don't let my opinion enforce you at all, right? I want you to understand different things. I'm open to different opinions, right? So this is an idea of scaling. What did I say wrong? What did I say right? And by the way, guys, I forgot to mention something very critical here. There will be a badass proxy right here. Oh, how about that? We do have a proxy. Nice. So all of this stuff we're gonna be done with a reverse proxy, right? That could be load balanced, right, to these master services, right? So technically, all of that stuff, right? All of these GET requests are going through the proxy first, right? It's going to the proxy, and the proxy decides, hey, go here, or go here, right? So that's the reverse proxy, right? And you can make unlimited copy of those reverse proxies, right? The reverse proxy doesn't only act like a load balancer purely load balancer and just do the funnel the request to all of them. No, it actually looks at the data, so it's probably a layer 7 load balancer here, and it looks at the data and says, oh, this is a GET request. I'll take you here. Oh, this is a POST request. POST request definitely have to be here, right? But GET request has to go here and has to go to this server, right? And probably there's a reverse proxy in niche, near to each data center, like in China, probably gonna have one, in Asia, and in Central America, and probably in Europe. And each one take it to the nearest server. And maybe the master server is gonna sit on America, right? So yeah, obviously write's gonna be slow for scaling purposes, but maybe you don't really care about write smash, right? But now comes to the sharding. Hey, I'm gonna shard my database. I'm gonna put a shard in Europe, so writes are gonna be faster, right? It's all about trade-off, guys. It's all about trade-off. All right, guys, I think that's it. I'm gonna stop here. What do you think? What do you guys think? Did you like this episode? How did you like this interaction of this spin thingy? Hope you really like it. Give me your opinion. Give me any critique that you might have in the comment section below, because I love to be better and do better with you guys, right? And then let's have a discussion. What do you guys think is the better way of doing things, right? Everything has a pros and cons. It's comes back to simplicity. Simplicity sometimes rules, and maybe simple thing can create the best design, really. While having complexity having complex design leads to complex implementation, which leads to the things that we all hate. Bugs! We hate bugs, guys. Okay? So simple design needs a simple, elegant implementation with code. And then once you have a simple implementation, you have a rigid, you have a solid, badass system. And when you have a badass system, you are unstoppable, guys, right? So paint, guys. Sit down and paint. What do you guys think? If you know where to start, start somewhere. Write something. Write anything that comes to your head. Okay, and that's why when I talk about backend engineering and system design, I need you to understand how databases work. I need you to understand how web servers work. So read. Keep consuming, learn and learn and learn, because we are all learning, guys, here, and we're not gonna stop learning. All right, guys, I'm gonna leave you here. See you in the next one. Leave a like, subscribe, and I'm gonna see you in the next one. You guys stay awesome.